The last topic I want to talk about for multiple regression is what the output looks like on SPSS, because I think it's a little bit hard to understand, but it also helps understand multiple regression a little bit perhaps. So what I've done is I've drawn two different parts of the output. So there's this coefficients table up here. This is my SPSS number 1. And then there's also a separate table that it produces called a model summary table. And so I just kind of want to go through this table up here first, because this is the stuff that's most familiar to us. One of the first things I want to point out is there's these 3 different rows here, right? So this is for the intercept. It's called constant, but it's still the intercept. That's where the regression line crosses over the vertical axis. And then there's going to be a row for every predictor variable that you have. And so for this particular example, we have studying and attendance as predictors. And it doesn't say the outcome variable anywhere here, but remember the outcome variable was exam score. Right, so we have our 2 variables and the intercept here. The next thing I want to go to is all the way over on this side. So the sig, that is the p-value, right? And so for whenever you're doing statistical tests with one of these statistical programs, to decide whether you reject the null hypothesis or not, you compare your p-value with alpha, which we always have set at 0.05. And if our p-value is smaller than alpha, then you reject the null hypothesis. And so here we reject all 3 null hypotheses because each of these is smaller than 0.05. Right? So the way you would interpret that for these is this is significantly different from 0. That means that this intercept is probably not wherever 0 is for the exam score. This 20 isn't close to 0. Right? And then this one and this one both are just that these predictor variables' slopes aren't 0, which would mean they're unrelated to exam score. But of course, the more you study, we find the better your exam score. The more you attend class, the better your exam score, and that's controlling for each other variable there. Right? So these sig values, these p-values, are a critical part of interpreting these outputs. And next, I want to talk about this section right in here. Right? And first, these are the unstandardized coefficients. And so if you're creating a prediction equation, these are what you want. Right? And usually we have this be a lowercase b, but for some reason SPSS decided to make it a capital B. Right? So if we want to do a prediction equation, we want to predict exam scores, we set that equal to our intercept value plus the slope times studying plus the slope times the value you put in for attendance. Right, so we could put in for studying, somebody who studies, I don't know, 5 hours and attends, I can't remember what kind of numbers we had here, 20 for X. Right, so they get 20 from that, 30 from that, plus the 20 for the intercept. So this person, we'd expect their exam grade to be 20, 40, 70. So that would be our predicted value for that person. Right, so we use these for our prediction equation. The standard errors are the familiar standard errors from all the t-tests that we have done. Right, so this is the standard deviation of the sampling distribution. Right, that's for here if we draw a normal distribution or something like a normal distribution. Right, that's kind of like what the sampling distribution would look like. That's what these standard errors are. So they tell us how much variability there is for these 3 different variables, or these 2 variables in the intercept. And these usually aren't of interest, but I want to point out that the t statistic, the t value for each of these, is the unstandardized coefficient divided by the standard error. So this, I'll write it in here, b divided by the standard error equals t. And so for example, 20 divided by 4 equals 5. Or 6 divided by 1 equals 6. Or 1 divided by dot 4 is going to be 2.5. So this t is the unstandardized coefficient divided by the standard error. Right, so we got all these, we talked through this and this. Last we have these standardized coefficients, and remember these are like correlations except for they're basically the correlation of the predictor variable with the outcome variable, exam scores, controlling for any other predictors. And so these, again, are interpreted just like a correlation coefficient overall, where the maximum value is +1, the minimum value is -1, and 0 means there's no correlation, no relationship. So if this is what our results look like, studying has a strong relationship with exam scores, very strong, all right, that'd be a strong correlation. Attendance, a less strong correlation, a less strong relationship with exam scores. And if this is what our results looks like, and somebody said, gosh, should I try to spend more time studying or try to attend class more? My guess would be, well, gee, studying seems to be a better predictor of exam scores, so maybe try studying more. So these are like directly comparable numbers, unlike these which are in the original units. This is 6 hours of studying, and this is like number of classes. So these are unstandardized, these are original units, these are standard deviation units. All right, so that's how you use the coefficients table. Last I wanted to talk about this model summary table here. This is useful because it tells us our effect size for multiple regression, which is often called multiple R or multiple R squared. And these are basically like a correlation of the outcome variable, which was exam score, with the predicted value produced by this prediction equation. So the multiple R for these results that I came up with here of 0.92 says that the actual observed exam score correlates very, very highly with the predicted exam scores. And R squared over here is 0.92 squared, 0.92 times itself. And this R squared here is basically the same thing as like eta squared was for an ANOVA. This is the percent of variance accounted for. So it's got a maximum value of 1, in which case the predicted value exactly matches the actual observed value for exam score. And a minimum value of 0, in which case the prediction, the predicted values from using these unstandardized coefficients, and you create the prediction equation, the predicted values are complete. If this is 0, they'd both be 0, then the predicted value is completely unrelated to the actual observed scores. So you'd get the effect size out of the model summary table. Yeah, so those are the ways that you interpret the SPSS output for a simple multiple regression analysis.